Question number 3 is another motion problem, and it says a stone is dropped from a bridge. It hits the water 3 seconds after it is dropped. What is the height of the bridge above the water? So again, we're looking for height. So if you want to draw a picture, we can just say the bridge has some height, and we drop a ball off of it. We're looking for the height, and we know that it takes 3 seconds for the ball to go from the top of the bridge to hit the water. So delta t equals 3 seconds. We also know that initially the ball is at rest. You also have to assume that acceleration is equal to negative 9.8 meters per second squared. So we go back to our equations and we say Vf equals V initial plus At, and Vf squared equals V initial squared plus 2ax, and we also have x equals x initial plus V initial t plus 1/2 At squared. These are only 3 of the 5 equations, but right away we know that we're solving for a height. So we want any of them that have x. But we also know we're given a time. So when we want to look at this, we could either solve for a final velocity here and plug it back into this one, or we could just simply use the entire equation here to solve for our height. We know that initial velocity we said was 0, so this whole term is going to drop out. So we have x equals 1/2 At squared. Once this term drops out, and the x initial, we can call it 0 because we're just finding the height. So if we do 1/2 times negative 9.8 meters per second squared times 3 seconds squared we get a height of 44.1 meters. Notice for the height I didn't put the negative sign in, even though acceleration has a negative 9.8 meters per second squared quantity, and that's because the heights here would actually be subtracted over, and the initial height is what we're solving for, and the final height is 0. So we're actually solving for the x initial, subtracting it to this side. Kind of looks like a negative x initial here. And when we solve for negative x initial, this term crosses out with this term to give us a positive number. So for question number 3, the answer is 44.1 meters for the height of the bridge.